Well, welcome everybody. I'm sorry we're running a minute late, and that is all my fault. Too many buttons to push and trying to get everything ready, but we are finally ready because I've been looking forward to this. Are you ready to take your brewing to the next level? Well, today we're discussing simplified water chemistry with Martin Brungard, and he is the genius behind Brewing Water. I'm Doug Piper. I'm the host of the Gourmet Channel, and I enjoy just talking to people like Martin. Earlier in the year, I've talked to John Mallett, Charlie Bamsforth. Matter of fact, I'll be talking to Charlie again tomorrow. For those of you that are in AHA, there's one on phone. So AHA members, check out Charlie tomorrow, and you could have to put up with me twice in 1 week. But thank you for taking time for joining us today, because we strive to make your day a little more delicious, one sip at a time. Now, please share in the chat if the audio and the video is okay, or at least my video is what it is. So you got to put up with me. But if it's all okay, that will reassure me that the show can keep going. All right, I see a thumbs up from Alfredo. Crispy, I see, is there. Let's see. Daniel, I see from Chile. Scott in Indiana. Wow, what a great crowd. Well, listen, let's bring on Martin. I want to bring him on just to prove that I've got him here in the audience, and he's here. And why don't you please write in the chat how much you appreciate him taking this much time. He actually rushed here from a big project that he was working on to get here in time for us. So please tell him how much you appreciate his volunteering his time today. Now also, I need another favor. Down there in the bottom, you'll see the polls. Please check those polls out and give me your short answers. It won't take you 30 seconds because that will help me frame up, because these webinars are for you. All of these I set up based on your preferences, and that's what we want to get. So let me tell you a little bit about Martin. Martin is the technical editor of the Brewers publication, Water, a Comprehensive Guide for Brewers. He's the genius behind Brewing Water software and the website. He has 37 years experience in civil and environmental projects, and he's the author of numerous articles and presentations on beer. He was also on the AHA governing committee, which I'm thrilled with. I need to get some tips from him. So if you're a first-time viewer, please know that we do monthly free events with subject matter experts. Our next one coming up, I'm going to try to do it from me. Oh, Stan Hieronymus is next month. So that's going to be cool. And actually, that's some of the polling questions there for Stan. This is our 89th free event, thanks to monthly supporters via our Patreon. And there's a lot of individual contributors, and they're in the chat, and I may post that again, but if you scroll up to the top, there was a bunch that gave some direct contributions to this webinar, and I really appreciate that more than you know. I'm just going to put those names right there, and these guys help make today's webinar possible. So please thank them in the chat. Gourmet Brewing is all community funded, and it's supported by your generosity and the ones of so many of you that support via the Crowdcast platform. Now, supporters in Patreon actually receive audio files, behind the scenes, brewery tours, including exclusive full-length interviews. For example, there's some from Ken Grossman and John Mallett recently. So please consider joining the team and supporting these events by clicking on the link there in the bottom center of the screen. We don't have any major sponsors. You are our major sponsors. So also click the follow button in the upper right-hand corner. I might be pointing to it. No, let's see. I think it's closer to over here. If you click on that, that will notify you anytime I do a live event. And then just some quick logistic things. Refreshing your browser solves most technical issues. Reducing the resolution, you can click a little gear symbol there in the lower left-hand corner. Continue to share where you're from in the chat. I see Scotland. I've seen all kinds of countries. So we really appreciate you joining us. Your questions might be the most important thing, though. So down in the center of the screen, maybe right about here, if you click on that, Martin will answer your questions in the second half. So we're going to try and do that at the top of the hour, top of the next hour. Thank you for choosing auto registration when you register. That way you get real easy access to the webinars. You'll just be automatically registered. And then contact me for virtual speaking or private virtual tastings or live events. I do those also. Now, what's coming up? Past the next events, what we got Stan April 26th, and he will have just returned from New Zealand, and we'll be talking about New Zealand hops. And I will have just returned from South Africa because I've been invited there to judge the African Cup. So there'll be all kinds of international discussion, I'm sure, for that one, but that'll be Stan. Coming up in May, Michael Tonsmeyer. June is Vinny Chirluzzo, and also John Kimmich with Vinny. They're going to kind of double team it there. So a lot of good stuff coming up. And another neat thing, in case you haven't had enough, at the end of the webinar, I will put a Zoom link. I'm going to put it in there now, but at the very end of the webinar, when we shut down, we will switch over to Zoom. So I'm going to struggle with that for a minute, so I'm not going to do that. So Martin, I am tired of talking about all my logistical items. Let's get you up on the screen. And I've got a kickoff question for you. Are you ready for the tough ones?
Why, sure.
Well, I think you'll find this one very basic and very easy, but it's kind of a burning question that I hear a lot. So the question is, how do I know when I really need to adjust my brewing water? And where do I even begin to start to do something about it?
Well, when you're dissatisfied with your beers, you know it's time to start adjusting your water. So it's really that simple. We will certainly be getting into how we're going to go about adjusting and learning to adjust and how to adjust and learning where you are and maybe even why those beers were going wrong in the first place. So let's have at it.
Well, in fairness and for a balanced program, I actually asked two other people a similar question. And if you don't mind, I'm going to play those. So our first expert, some of you may have heard from, is Mr. John Palmer. So let's hear what John says, and I want to hear what your thoughts are when we're done with it.
So does water chemistry really matter to your beer? My short answer is yes, it does. Water chemistry affects the mash chemistry, which affects the beer chemistry, which affects the flavor of the beer. And the magnitude of that effect varies depending on the beer style, the strength of that beer, your taste preferences, and lots of other factors. Why does this effect vary? Well, simply because brewing is cooking. Your ingredients and your water composition are your salts. That is the seasoning for your beer, just like salts and herbs and spices are seasoning for your cooking. So you can cook by experience, or you can cook by a recipe, which is someone else's experience. But in each case, you're making decisions on ingredients and amounts because the seasoning matters to the taste. So water chemistry may seem like a esoteric kind of thing. Does it really matter? But yes, it does. You have to understand how it integrates into your final beer.
Well, what do you think, Martin?
Oh, he's got it. John and I worked together on that water book, and God bless his heart for pulling through and making that thing a reality. I was glad to be able to support him, but he knows what he's talking about.
So do y'all always agree on the amount of calcium in the water?
Oh, probably not, but it turns out that the amount of calcium isn't all that important, so it's okay.
Oh, so that's your answer. I like that. Okay, well, not to be outdone, we also have Mr. Denny Conn to weigh in on this. So if you don't mind, again, I would like to hear your thoughts on that, but let's switch over to Denny right quick and see what Denny thinks.
Hey, beer fans. Doug asked me for a few thoughts about water, so here you go. Based on 25 years and 600 batches, this is what I've learned. If you do nothing else, get rid of chlorine or chloramine if your water has it. That's the most important thing. Best water treatment is the least you can do to get the results that you want. Numbers are more important than ratios. 2-to-1 and 200-to-100 are both the same ratio, but they're going to give you very different results. Adjust minerals for flavor, see what that does to your pH, and then adjust your pH. I see too many homebrewers acting like pH is the full deal, and it's not. It's just a part of the picture. And I guess finally, and maybe most important, pay attention to Martin. That's what I do, and it works for me. Who's Denny? Going out. Bye-bye.
Well, what do you think?
All right. Denny is the bomb.
He says we should trust you.
Well, I happen to have some insight that sometimes is right, so why not?
Anything you and Denny kind of spar on sometimes?
I would probably differ from him on that pH issue. Make sure that you're targeting a pH. Now, if you're using a good software, more than likely you're gonna account for those mineral additions that you're doing for that seasoning thing that John mentions. But then, with the proper software, you can predict where that pH is going to be with some accuracy, and you just let that ride. And we'll get a little bit deeper in the pH here during the presentation. So let's launch.
Well, good. I would say let's go ahead and get started. I know we've got 2 beers to go through, and then we'll jump in. Looks like you got 11 questions already, Martin. So they're I think everybody's going to, 12 already. So let's jump into it. So I would love to know, how's the best way? I mean, I think I have some of the best water in the world here in Greenville, South Carolina. How should I evaluate it? What should I do?
Well, first of all, knowing what's in your water is the first thing. As you point out, Doug, Greenville happens to sit on the foothills of the Appalachians. The water quality is probably pretty good. Not very hard, not very full of minerals, probably not very that alkaline either. But knowing what's in your water, in essence, knowing where you are, allows you to then move forward with what you're going to do next. So there's things like the water department report, like if you're on a municipal water supply, you can often contact the water department, and they might have some of those parameters that are of interest to brewers. Now, they aren't required to have those, so you might be batting a zero there. But the next step is to actually send your water off and get it lab tested, and with that, you've got a very good amount of information with exactly the kind of ionic content that you need for brewing analysis. Kind of maybe a third best option is aquarium test kits, and there's only a few that are really valid here. The calcium content, aka hardness, and then the alkalinity. And some of your brewers might say, "Oh, it's a test kit. It's not that great." Well, aquarium people are pretty particular about their water quality. So those aquarium test kits are often pretty decent quality. So you can get in the ballpark pretty well. And then the third thing, I know that a lot of people complain about, oh, my water supply, I can't depend on it being, consistent and all that. Well, a simple TDS meter, a total dissolved solids meter, that simple at, maybe $20 to $30 little electronic meter. It has a readout in total dissolved solids. That will give you a good indication of when your water supply does vary, and then you can say, well, hey, you may still be in the weeds with that, but at least you knew it changed. And if you
Okay, I got to interrupt on that one because I've been wanting a TDS meter. I don't have one. And because some of the coffee work I'm doing, they recommend them, and they're not cheap. Is there an aquarium version?
Oh, they are cheap. They are cheap, and they are an incredibly simple machine. It's in essence 2 electric probes and some electronic wiring, and voila, you're on your way. So there's no reason why they need to be expensive at all. If you're getting a little bit too high a quality there, Doug.
Well, I wouldn't that. So, I mean, if you go on Amazon and there's one for what, $15, I mean, you can find pH meters for 15.
Well, and these TDS meters are, like I said, very simple. There's no reason why you can't find one for $20, $30, no problem, and it will be very reliable. You'll have to change the batteries every once in a while.
Okay. It sounds like a cheap TDS meter might be better than a cheap pH meter.
Oh, for sure. Cheap
Okay.
pH meter, you definitely get what you pay for. So
Okay. All right.
Don't be
All right.
cheap.
Keep going.
Okay, so your water doesn't need to be like rainwater. Doug, you might be lucky in that your tap water is a little bit closer to rainwater than other people. But if you've got, say, less than 100 parts per million calcium, maybe less than 20 parts per million magnesium, less than 70 parts per million sodium, and less than 70 parts per million sulfate, and 70 parts per million chloride, you probably can brew with that water on a lot of styles. There's some that you might be a little bit outside and there might affect the beer, but probably not enough to really screw up the brew. But the other thing that you'll need to be watching for is making sure your bicarbonate content, the alkalinity, is less than 250 parts per million for the bicarbonate. So if your tap water happens to fall within that limit, well, you've got a decent starting point, and you can start, as long as you've figured out, what those true numbers are, you can actually get going with this and make a difference to your beer. So so that's a broad brush of what good brewing water, or I guess the limits of good brewing water, can be. And one thing I like to say is, hardness, i.e., the calcium and magnesium content, they can be kind of high. So having a lot of hardness is not a bad deal, but having a lot of alkalinity, that can be a real killer. And we can deal with alkalinity, but there's only so much that you can deal with. So with that, those are the basics. So Doug, I'm getting a little thirsty. How about you?
I am too, but before I go there, I want to ask now. You're right. I think Greenville's water is pretty good.
I lost you. Okay, so I guess I'm good. So let's go ahead and pop the top on a Kölsch. I've got the Fru. I know Doug will have a much prettier presentation than I can do, but I wish I had an official Cone stang to share with you, and I might as well put this up so you can actually see it. My Willy Braun glass will have to do, but as you can see, nice and pale, nice and clear, and hopefully Doug will be back on here shortly. But yeah, let's talk about this Kölsch. So a lot of pills, typically almost 100% pills for most brewers, and there might be some a little bit of wheat if they're having heading problems. As you can see, Fru does not. So those are the two main ingredients, and always German hops. With their I guess traditional flavors. And then in a real important aspect for a good Kölsch is to actually use a Kölsch yeast because it provides that fruity, winey yeast character that is just so important for this beer. So it's a good one. Okay, I would say yes, I do see brilliant clarity. If I can keep the condensation off the glass. Here we go with Doug and his pour. So have at it, Doug. Oh, and he tells me that Fru recommends that you wet the glass before you pour.
I did. I have a cold water rinse. I am prepared.
Oh, that's so good. Oh, yeah. So this reminds me of sitting in one of the tap rooms in Cologne. And by the way, turns out that Cologne is actually a sister city of Indianapolis, where I sort of reside. So let's talk about the water quality in Cologne. 40 parts per million calcium, 10 parts per million magnesium, 25 parts per million sodium. And a lot of people say, oh, I don't want any sodium in my water. Well, that's not really true. We'll get a little bit deeper into that later in the presentation. Now, here's something that some people will probably find surprising. There's 70 parts per million sulfate in Cologne water. So those of you who think, oh, sulfate is terrible for beer, that you want to be malty or whatever, yeah, not true at all. And there's 35 parts per million chloride in this water. So, and it turns out that Cologne water is actually very similar to Jever water, which is Jever is a town in Germany also that is famous for their German pills. So literally, the difference between this Kölsch and Jever pills is the amount of bittering that's applied here. So this one is about probably 10, 15 IBU lower than the Jever pills, and it's a crisp, cold, very refreshing beer. Man, I just love when you're sipping it out of those little 200 milliliter stangs in the bars there in Cologne. Strong German maltiness. Places like Fru, Sion, Sooner, Gaffel, Riesdorf, Malzmühlen, great places. If you haven't been to Cologne, you need to go. Okay, Doug, any comments? What'd you think about the beer?
I hadn't tried it yet. I was having so much fun pouring it. They had really stressed I needed to get a great head on it. I want you to know I about got it. I mean, Check that guy out.
That's nice.
So apparently wetting the glass really helps. Reading the
Apparently so.
directions.
Yeah.
So,
I did not have that luxury.
ooh, nice foam.
Yeah, and I'm loving the fact that Frew and a number of the Kölsch breweries, the official Kölsch breweries like Riesdorf, Golfel, and Frew, are now doing these, half-liter cans. Great packaging method. Uh, it makes the trip across the pond, so we get to enjoy great beer.
Yeah, this is one drinkable beer. Oh my gosh.
Well, like I said, when you're drinking out of little teeny glasses like only this big, you're popping these things back so quick. It's just so much fun.
What is what 4.8 ABV?
They're about. It might be a little bit lower. Yep, 4.8. You are right.
So John asked about the alkalinity of Cologne's water. Can we talk about why you chose this beer for a water program?
Well, probably most importantly, because it was that kind of anachronism that some people have, thinking that you would never have sulfate in a beer this malty, but that sulfate serves a very important purpose. It dries that finish out and makes, so you've got all this nice maltiness, but you do want it to disappear. And if you just load all your water, if you started out with RO or distilled water and just threw calcium chloride in your brewing water, you're going to end up with a perception that that the malt just never leaves the malt lingers too long in your palate, and you just never dries out. So with this balance, you get to clean it out, and it invites you to take that second drink and third and fourth and however many it is. So enjoy. So we, with regard to the alkalinity, it's not terribly high. So it's it's certainly controllable with an appropriate dose of acid, and because this is a continental brew, it will always be lactic acid. They don't use phosphoric, they don't use hydrochloric or sulfuric or anything. It's always lactic acid. So and it may come in other forms, so acid malt and sourgut, but those are just another form of lactic acid. So
so if you were going to brew one of these in your hometown,
sure,
how would you do it? Because we're going to kind of talk about styles and the importance of figuring that out.
Well, I do brew this, and because my water in this particular city is kind of hard and some kind of alkaline, I do have an RO system, so I start from zero almost and build up. And the alkalinity is not a big deal, but so water with high temporary hardness, which Cologne water does have pretty decent temporary hardness. Much of Bavaria, which Cologne is outside of Bavaria, but all of Bavaria has got water that is very high in temporary hardness. You can boil that water and drop out a bunch of alkalinity and hardness, i.e. the calcium, and it becomes a very nice water, as anyone who has had a Munich Helles or Munich Dunkel or any of those Bavarian styles knows. They make fantastic beers there, but you will probably have to add some form of acid in order to to make that water cooperate when you're dealing with a really nice pale beer brewing like this. So all brewing requires acid. That's rule number one in a fact. There is no brewing that you will not add acid to, but I'll just let's go into how we add acid. So of course, I guess the easiest way would just to be add acid. So for instance, adding phosphoric acid or lactic acid, or in England, the CRS, or those kinds of available food safe acids. They are a possibility. The other way to add acid is to add calcium or magnesium salts, which combine with the phytin in the malt to create another acid. Another way is to add either roast grains or crystal malts. Either of them tend to be very acidic, and the darker they go, well, of course, roast is already dark, but some of those crystal malts, especially say the 120 or 180 Lovibond crystals, they're outstandingly acidic, and they can provide the kind of acidification that you might need in a particular thing. Other options for acidification, there's an acid rest, part of the your mashing approach. Acid malt. Be careful with acid malt, especially if you're switching between one maltster and another. The acidity in that acid malt can be off by like a factor of 2, so be careful. And then if you're a real brewing aficionado, you can do what is known as sour gut, which is soured wort, where you are in essence running off some fresh wort and allowing it to become inoculated with lactobacillus. Lactobacillus, and you create this acidic brew that is then added to your mash or your sparging water or whatever, in order to provide the kind of acidification you need to control your brewing water. Okay, so figuring out how to dose your strike water and sparging water is really the key to good brewing results. So keep that in mind. So I think many of you know that pale malts tend to have a distilled water pH in the 5.7 to 5.8 range, but I think that hopefully many of in the viewership know that you really want your mash pH to be in that 5.2 to 5.6 range when measured at room temperature, of course. That's the important thing. And as you can see there, so those pale malts, they don't go low enough. So you need to do a little something extra in order to get that pH down. So just remember that. Okay, Doug, let's show those pH slides, the PowerPoint ones.
Yeah, the ones that'll take me a moment to bring up, since I had a blue screen of death. I want you to know when I froze up. So give me a moment to bring that up, and then I'll pop it on screen. So keep
Sounds
going.
good. Thank you, sir. So of course, so having an improper mashing pH can end up affecting the finished wort, and it ends up screwing up a lot of things. So there turns out to be a bunch of reasons why you really should pay attention to your mashing pH and make sure that you get it at least in the ballpark. You don't have to be exact, but you gotta be in the ballpark, because if you're wildly out of range, hopefully we'll get to see these slides.
It's coming in just a moment.
Well, I'll talk on them. So as I mentioned, you need to drive the pH down because a pale malt by itself isn't going to do it. So adding those wrong slide. Okay,
Figures.
so
I'll get it just a second.
So high wort pH effects, and for most brewing, most of us are brewing pale to maybe amber colored malt beers predominantly, but you're more likely to have a high wort pH and have it being deleterious to your beer. So reasons why it affects the malt. It extracts tannins and silicates out of the malt grist, so you don't want high wort pH. It also impedes starch conversion. It dulls the beer flavor. It becomes a kind of a muddy. It loses some of its crispness. There we go. Next slide, Doug. There you go. It darkens the wort. And it also affects the hops. Which is the next slide, Doug. Extracts polyphenols from the hop body itself. That's that sort of green chlorophyll taste. It does create a harsh bitterness in the beer, and it clearly alters the hop flavor. So you want that wort to be in the proper range in order to not screw up your hops. And then next slide, Doug. It also affects your yeast. Oh, excuse me, or thank you for for that, Mr. Kölsch. It interferes with the yeast flocculation. It increases the contamination risk because one of the uh, uh, protective actions of yeast is that they drive beer pH down. And if your wort is starting, much higher, and your yeast has to work it even longer to get the pH down below that level, which the beer spoiling organisms can be dealing with, it increases that contamination risk. And then finally, you end up with a higher beer pH in the end, and that's just not so great. So that's the end of those slides, Doug. Okay, back to the real one. Okay, let me get back on track here. Okay, so the correct amount of acid is needed. Too much, and if you drive the pH down below 5.2, that can be really bad, because then it turns out that there are enzymes that work better at certain pHs. Well, it turns out that the protein proteolysis enzymes actually go crazy at that low pH, and you end up chopping up all the body of your beer, and you end up with no body. The beer ends up sharp and acrid, and it's just not that pleasant. So you don't want to go too low. But then if you're a little too high with a pH greater than 5.6, then you run into the possibility of those tannins and silicates. And tannins and silicates tend to be sort of harsh flavored, that chewing on grape skin kind of thing, and it's really just not a pleasant experience. So that's something you'll want to avoid. Of course, we've already mentioned the darkening and dull flavors and the poor yeast performance. So you're looking for that 5.2 to 5.6 range and trying to stay in there, and 5.4 tends to be a good spot for it. So there are times. So let's get back on track here. Okay, so one thing I'd like to point out in Brewing Water, the software that I've created, it does separate the water treatment for your sparging water and your strike water separately. So you don't mix up just one batch of water and run with it and use it for everything, both mashing and sparging. No, you need to tune the mashing water chemistry separately from the sparging water. Sparging water always has an alkalinity less than about 50 parts per million as calcium carbonate, but preferably less than 25 parts per million as calcium carbonate. So that's sort of a fixed number, but the alkalinity or acidity of your mashing water could be very, very different from that sparging water. So that's an important fact that I want everybody to understand and practice, because you're not going to be very happy with the beers treating it all as one. So you may have, so for instance, if you're brewing a very dark beer, you might be looking at, you need a more basic, more alkaline water chemistry in order to avoid that mash pH from going too low. So then, having that's clearly quite different from the kind of water that you would need to brew a very pale beer like this Kölsch, where we needed to add some acid because unlike in the case of the dark beer where we got a bunch of acidity from those dark grains, we don't have that. So we need to add that externally, and there can be differences to reflect there. So Doug, let's show that other uh, time to pH figure.
This is a test, right?
Well, that's the other the one you had up there previously. There we go. Okay, so this shows what's going on with the differences between, say, a more basic strike water that you would use in the case of a dark beer brew or dark beer mash. And that water is going to have and these are semi-made up pHs, but that water, if you either, if it was a natural water, it's going to have a pH and alkalinity well above, the pH well above 6 or 6.5. And in the acidic strike water is something that you would use in the case of a pale beer brew. And just the water alone, without any grain in it, it's going to have its pH is going to be well below 4, and for that reason, I'm showing this particular graph, which is, and I'm not sure, Doug, are we seeing the? Let me
You want to zoom out?
Yeah, we do need to see, no, yes, zoom out, because on the bottom is a time scale. So this is pH versus time in a mash, and as you can see, initially if you were to measure the pH within the mash or take a pH mash sample or wort sample, it would initially at time 0 be very low or very high, depending on which water you were using. And as you can see, it tends to I guess zero in on the targeted pH that you've established. So in this particular case, a targeted pH of 5.4 was employed and assumed. And in either case, over time, pH will stabilize. So I know there's a lot of people out there that think, oh, I need to measure pH early in my mash, and that's the one that matters. No, sorry, that's not the one that matters. And as I'm proving with this graph here, it can be wildly different. So for instance, the EBC, European Brewing Congress, or ASBC methodology for establishing DI pH for grains, they test that at the 30-minute mark. But of course, both of those methodologies, they pulverize all the grain when they do that, so they get much better extraction much quicker. So for us mere mortals who have to sparge and lauter your wort, you've probably got a little bit coarser grind, and it ends up taking roughly about 45 minutes for the wort pH to become constant. So it may start out high if you're brewing with an alkaline water that needs to descend. And by the way, this tracks very well with the amount of extract that you draw out of the grain. So if you're using your refractometer during the mashing period, you can actually track this and get an idea of what's going on with why this occurs. So that wort and the constituents within wort are very strong buffers, and that's why we see this change in pH or mashing pH throughout time. So this is a factor that I'd like for you to consider next time you're doing this.
So, Martin, I like the question that Kevin asked. So, when should you measure the pH?
Yeah, at rough, I feel that you should measure pH throughout, but just understand that there will be a variation as your mash progresses. Your go no go would be roughly that 45-minute mark. That's when things should have zeroed in and become constant. So measuring early, you're deceiving yourself. So rely on that later mash reading as your indicator of success, and for your future adjustments to your brewing regimen.
All right, so Martin, I've got a Cold Stone IPA here. I'm ready to open, but I actually have a question.
Sure.
Since there's the 2/10 or 3/10 of a difference in your mash pH as a result of temperature.
Yep.
How do you recommend? You said multiple times through it. Can you give us the practical side of this and dealing with the temperatures? Because, go ahead.
So yes. So a lot of people have some difficulty. Is think, oh, my pH meter has got automatic temperature compensation, so I don't need to worry about it. Well, that's not true. That only corrects for what the measuring device sees with its electronics. There's an additional sort of chemical aspect of that temperature change within the mash or within the wort that is not reflected. So if you're measuring pH at wort temperature and probably destroying your pH meter, you're not getting the full picture. So that's why we're standardizing, and when we're talking about the kind of ranges I've mentioned, 5.2 to 5.6, those are room temperature measurements that are relatively universal. So it's a good practice. It's better for your meter. It'll last longer. And I don't know about you, but I like for my equipment to last as long as I can make it last. And I can guarantee you that sticking it into hot wort is a bad thing.
So, so how do you avoid that? I mean, what's the
Okay,
practical side of it? What do you? So you got this hot wort. You need to test it. You want to get it done quick. How do you do it?
sure. And it's fairly easy. So I have a small water bath, a small ice water bath, and I've got little uh, stainless steel shot glasses. So they're little, metal. They're not glasses, but they're shots. Uh, Put enough wort in there so that you can submerge your instrument. And that's another reason why I hate those all-in-one units with that have a very large head to them. I like the small probes, a real lab probe, which is probably half-inch diameter. Um, they fit in a proper shot glass. So you put that hot wort in that stainless steel cup, just put it in the ice water bath, swirl it for a minute or so. I also use a temperature probe in there just to check to make sure, because you do want to bring that wort temperature down to into the 20 to 25 degrees Celsius range. It's not terribly critical to be exact, but somewhere in that range, and then test. And you can do that in about a minute or two. So I'm measuring my pH every 15 minutes during a mash, and I only spend a couple of minutes collecting the sample, getting it chilled, and getting that measurement. And anybody else can do it too.
So stainless steel shot cups,
Yeah, shot cup. Okay.
for lack of a better word,
Yeah.
uh, and make sure your pH meter has a small head, pencil, I guess more cigar size head.
Sure. And of course, if you've already got a big pH meter, just go ahead and find a cup that hopefully will fit it, and use that in your water bath. And like I said, don't just leave it in the water bath, because you can chill it too much, and then the pH, it's just as bad as dealing with a hot wort. If sticking your pH meter in a very cold wort also doesn't do it any good, because that same thermal stress on that very thin glass bulb still occurs.
So, Martin, how would you summarize styles where water chemistry is key?
Well, um, uh, are we that long? Well, I guess we are that late, aren't we?
Yeah, we are.
Oh, okay. We've had too much time. Fun here. Okay. So styles where chemistry is key. Well, there are plenty of them. Light lagers tend to be keyed, because they have low mineralization, and that water tends to keep out of the way. It's not part of anything that you taste. You're just tasting malt and maybe some hop. Dortmund export beer has a very high sulfate level. Uh, they've measured 300 parts per million, which is not crazy high, but when you combine that with the over 100 parts per million chloride, that is the reference for or the recipe for minerally. So um, it's something to consider. So yeah, Kölsch, again, I mentioned that high sulfate, 70 parts per million compared to the 35 parts per million chloride. Surprises some people. Scottish shilling styles. Scottish water around Edinburgh tends to, because there's a lot of coal mining in that region historically, there is a lot of sulfate in that water, up to 140 parts per million, and only 50 parts per million chloride. And I'm sure that many of you have had those Scottish shilling styles, the 60, 80 or 60, 70, 80 shilling beers. They're still very malty, but, people don't recognize that, yes, they are very malty, but because of that sulfate, they dry out so quickly. So makes them very refreshing, very drinkable. Burton beers, very high sulfate, very modest chloride. Sulfates in the 200 to 600 parts per million range. That's getting on up there. Chloride in 35 parts per million. Magnesium around 40 parts per million. That's getting on up there too. London beers, actually, you've got two different kinds of water within London. You've got the Thames water, and then you've got the groundwater, which is from the chalk aquifer, which was used for the porters, London porters, and that is the reason why London porters were revered the world over. It was high alkalinity water that also had a significant amount of sodium in it because it saltwater intrusion, and that added to the flavor. And I guess since we're running out of time, I'll point that John Palmer did some trials looking at sodium in beers, and until you get into, like, say, over 100 parts per million, you really don't have a problem with sodium. So people freak out all the time. I don't want to add sodium to my beer, and the old sea dogs sitting in the bar putting a shaker of salt in their mega lager. They know that improves flavor, and you should know it too. So don't fret up too much about sodium. Let's cover West Coast IPA since we've got that sample. Sulfate in the 150 to 300 parts per million range, and chloride only down in the, say, 70 range. They are built to display hops, and that's an important fact. Having all that sulfate in there helps clear the palate so that the hops can do their business. And kind of the antithesis of that is New England IPA, which has got say 70 parts per million sulfate. Kind of the opposite of what we just saw with the West Coast. But the chlorides are way up at say 150 parts, and that's to provide that mouth mouth coating, lingering perception that you're just bathing your mouth in malt and hops and enjoying the entire sensation. Now it doesn't clear out very quickly, and you may not necessarily want to drink it too quick, but it's good beer. So Doug, let's have that next beer.
I thought you'd never ask.
I know.
So while we're doing this, and we've got 21 questions so far, I say we. That's really you.
Okay.
So drink up. Let's touch on. You mentioned RO water, and since that's what you brew with, and some people may be forced. They may not have RO, but they may be buying water that's from the grocery store. So, what would they do? Can you touch on that?
Well, so you're still left with that same problem. If that grocery store water doesn't provide you with an analysis with the calcium, magnesium, sodium, sulfate, chloride, and bicarbonate content, you're still in the dark, and it's difficult to know where to go from there because you don't know where you are. And quite actually, for a lot of these grocery store waters, in some cases, it's just they just went out to some city and started filling up jugs. And well, they probably have taken out the chlorine, typically, hopefully, but that is probably the only treatment they've got. So you're brewing with tap water, and it's not necessarily better. So it's an important fact that you need to know where you are before you decide where you need to go. So, uh, so
So if it comes with, I mean, does any of the bottled water that you know of, I guess big brands, that actually comes with like a breakdown?
there are. So and definitely stick with them. So if you insist on going with those bottled waters, if they've got a complete breakdown of all the ionic content, you can brew with it. And of course you'll need to plug those things into a water calculator and then plan your brew from there. Depending on what style you're trying to duplicate. So that makes it a whole lot easier when you know where you are and then you go where you need to go.
Look at the head on that guy.
Oh yeah.
Isn't that pretty?
So I talked to Mitch Steele earlier or late last week. Turns out that Stone brings the sulfate content in this particular beer to 150 parts per million sulfate. So really not that drying at all. And I think that that is clear with what I'm tasting. I mean, this one does not clear off your palate very quickly, but it's good enough. And for a I guess a nationwide mega IPA, it's good. I tried to get the same information out of Vinny since I've been dealing with him here lately, and he would not divulge. So
Oh,
I
really?
I do not know, but I also deal with Matt Cole over at with his headhunter. I'm at a loss for where Matt is.
Can't
Headhunter
help you on that
IPA.
one. Well, so if I was going to brew a West Coast IPA and I was in your hometown, what would I do?
Okay, so in my case, so here's a condition where it might actually be okay to brew with some of my tap water because I need some of the alkalinity because I'm going to have to dose it with a big slug of gypsum and some Epsom salt in order to get the sulfate where I need it to be. And I personally like 300 parts per million because it's a very nice, refreshing, dry jolt. Oh, and to close the story out with Matt Cole, he brings his for his Headhunter IPA, he brings it to roughly mid 200s with sulfate. And that's probably one of the reasons why he's won. We're I guess it's not World Beer Cup, but GABF with that beer. So it is nice and bracing, and it's an enjoyable tipple.
Kevin suggested Fatheads. Is that
Yes, Fatheads is the brewery.
So, in summary, Martin, when you're looking at having to brew with RO water or store water, what would you recommend? What kind of the steps to get it right? Just kind of a quick summary.
Okay, so it's always easier to add minerals. It's very difficult to get that content out of water. So starting with a store water that say is glorified tap water, it may not be as smooth as a sail for some styles. But as I pointed out when we opened this presentation up, you know, there are a bunch of styles that you can get away with brewing with fairly mineralized water. So you don't have to start with RO or distilled water, but it certainly is an easier step. And the other good thing about starting up with RO and distilled is that you don't have any alkalinity, and at least you don't have to acidify as much. Excuse me, beer's talking. So, uh, yeah, it's like I said, easier to add than it is to take away. So let that guide, and not all beers need very low starting points for your water. So you might be able to go with that store bought or tap water.
And you had such a beautiful choice of beers. I thought I would show that on screen. Ooh, a little bit tilted there.
Yep.
How about that? There we go. That looks a little better. So we can see a little idea of the difference in the coloration. But nice choice of beers, Martin.
Well, we had to get a good wide distribution so that more people could actually sample them with us.
So I think we're ready to transition to the questions. Now
Sure.
we're a little past the top of the hour, and my apologies to those of you that only allow an hour. For those that have time, we will go through the questions. We will take them in order of priority, which means they're actually voted. Everybody gets one vote, and you can push the most important question to you up to the very top, which means we do those first, and Martin will spend the most time with those. So
Okay.
I would suggest you peruse through those questions quickly and vote for the one that you would like to hear the soonest. Now, the other cool thing for those that need to leave, if you ask your question, we will email you. My audio is low. Maybe I'll get a little closer here. Sorry. I think I can help here. How about that? Oops.
That's
Too
good.
much. Sorry. Thank you, Todd. We will email you when Martin is answering your question, so you can jump on if you want to hear it live, or if you don't catch it live, you can actually, join later, and you will actually take you right to that question. Crispy, thank you. That's what happens when your computer resets in the middle of a webinar. So I appreciate the feedback. That's why I always ask, how's the audio, how's the video? So anyway, we'll transition into that first question, and let's see who's got this. So Sheldon has our first question and he has the most votes by far. So let's jump into that. And Sheldon's question is, how can I reduce the bicarbonate level of my hard tap water? It's about 180 parts per million.
And that's the actual bicarbonate as opposed to hardness or alkalinity. So I'm making that assumption. But acidification, and that is too high to sparge with. That's going to get you in the trouble with the tannin and silicate extraction. So you will want to treat that water and take it down, preferably with a liquid acid. 180 parts per million. I cannot recall. I think that is going to be low enough that you could actually use lactic acid. Excuse me, beer talking again. 88% lactic acid. Phosphoric acid is also a very good choice, especially if you want it to be very clean. Personally, I find that lactic acid adds something when it's in modest use. Roughly, certainly no higher than 1.5 milliliters per gallon of beer or gallon of water. Will keep you out of the taste threshold for lactic. But yeah, the bottom line is, get a liquid acid and employ it here, and you'll take care of your alkalinity for your sparging water, and then you'll separately deal with you'll establish whatever alkalinity level that you need for your mashing liquor, your mashing strike water.
Great question, Sheldon. I appreciate that. This thing is not exactly accurate at the moment, so if I miss yours and it was highly voted up, I'll just let you know my system is not working as well as it should. So I think Scott has the next highest question. Scott asks, is temporary versus permanent hardness? So what does this really mean, and how is it important for my brewing water?
Okay, so hardness is any divalent ion in drinking water. That generally means calcium and magnesium. So calcium and magnesium are high in hard water. And if there's a lot of bicarbonate or alkalinity that's paired with that hardness, then we call that that resulting water has temporary hardness. It can actually be boiled and it will drop part of that hardness out. But if there's very low alkalinity in that water, and there are waters out there that are this way, they can have very high sulfate, very high chloride, along with the very high calcium and magnesium, with very little bicarbonate. Under that condition, that has what we call permanent hardness. There's not enough alkalinity in that water to allow that precipitate that you can't drop the hardness like you can with the temporary hardness. So it's in the water. You can boil it all you want, and you're not going to change the hardness. So that's really what that term temporary versus permanent. If it can be boiled and softened, that's temporary.
Great question there. All right, our next one. Again, I'm going to have to scan through these. There's 2 votes. All right. So from what best I can tell, James has the next one. It's kind of a long one. James says, I'm a craft brewer, and we're having trouble with our pH. Now, I've been trying to figure it out, but I think it has something to do with our bicarbonate/carbonate levels. We are currently using a 5-star 5.2 a 5-star 5.2 additive. Sorry, wasn't familiar with that term, which I recently discovered is ineffective. So I'll likely be moving to phosphoric. Are there other ways I can better control my pH in my mash? We have 2 different water sources, fall and spring. The spring water is giving us mash pHs of 5.7 to 5.9 regularly, and he might have run out of room at that point.
Well, okay, so thank God you've discovered that 5.2 is, yeah, it's unfortunately snake oil. Shame on 5-star for continuing to put that product out. It is ineffective, as you've already found. Moving to phosphoric is a good idea. It's a safe option for you. You bring up that point where you've got that changing water sources, and that's where that TDS meter and the aquarium test kits can give you the kind of insight that you need to be able to plan your brews a little bit more effectively. So if you start, and I would say monitor your water year round, and when you see that the TDS has climbed to something that's very different or out of range, go ahead and collect a sample, get that sample tested, and then when it goes back down to some more regular level or something like that, again, have that water tested so that you at least understand what the range of your water quality is. And with both the TDS meter and potentially those alkalinity test kits, at least you can in your own brewery understand the calcium level, because there's a calcium test kit, aquarium kit, and then the alkalinity kit. Both of those can be used to help guide what you're going to do with your water. So, it's a little more complicated, and I realize there is not a simple answer here, but at least there is a way that you can get to some competency with this variable water that you're dealing with.
That Kölsch is particularly nice.
Oh yeah.
I know Mitch brews a good IPA, but that Kölsch is I'm really enjoying.
Well, of course, it's not Mitch brewing this one anymore, but
I realize.
he's right down the road from you.
He is. He is actually.
Atlanta.
He is putting a location in Greenville, about a mile, less than a mile from my house. So I'm looking forward to that. And Mitch promises a discussion on that. So
good.
That'll be fun.
He's the IPA man.
I know it, but this Kölsch is not. So how do you pronounce this right? It's Fruh. I'm probably pronouncing it
Fruh.
And that's correct.
Okay. That's okay. I heard.
That is a nice Kölsch. Yeah, it's a nice choice. It's my first one. Okay, Kevin has the most popular one. Is chalk important? Do you have any tips on how to dissolve water salts, especially for stubborn minerals like chalk?
Well, so chalk is soluble in water, but it's soluble on a geologic time scale. And since we brewers do not work on that time scale, it's really best if you don't deal with that, but you can get chalk dissolve. For instance, if you only needed a couple of tens of grams of chalk, you could put it into a 2-liter bottle with distilled water or whatever. Put one of those carbonator caps on there. Charge it up with 20, 30 psi of CO2 and shake the piss out of it, and you will see that you can get a whole lot more of that chalk to dissolve. The problem there being that until you get it all to dissolve, you won't actually know what kind of alkalinity you're dealing with. So my strong advice is, if you actually need alkalinity in your mash to achieve a certain pH within, say a darker, stouter or porter or whatever, you're really better off with baking soda. Baking soda dissolves completely. It is not a problem that it has sodium. As a matter of fact, as I pointed out with the London porters, they were using a water that was very high in sodium, and the amount of sodium that you're adding with baking soda is minuscule when you consider that you're only adding that baking soda to only the mashing water and not the sparging water. So when you add everything up, the amount of sodium added is very small, and more than likely this was a dark beer, and more than likely it's going to be a taste advantage to have that sodium in there. So baking soda is what you want.
What a good tip. Great question, Kevin. I have struggled with that myself. Oh, Dennis has got a bunch on his question. So, and actually, I think that may have the most votes so far in the evening. So I think a bunch of folks really jumped onto this one. Dennis asks, how does using acid malt versus acidified strike water affect the time at which the pH stabilizes? Now, before you answer, Brian Hovey weighed in. So, is it that we can't adjust the mash pH during mash? We can only learn for the next brew? ?
Bottom line is that's the way that you really should do it. You really should. It's not a so throwing grain into your water and checking the pH and then adding acid, that's just idiocy. Just absolute idiocy. Don't do it. Use a pH prediction program to help guide you so that you already know about how much acid you want to add before you add the grain and the water together, so that you're going to end up with the proper result. So don't that's called chasing your tail, and you can end up really going way out of line with that kind of crap. I've heard people, my pH was too high, so I added some acid, and then it was way too low, and I needed to add I added some chalk, and just don't.
Well, that begs a suggestion. How do you do that? How do you recommend doing that? You know a good way to do it?
Well, of course, my personal preference is brewing water, because it's people like Denny Conn helped me actually calibrate and make it work right. So it's gone through hundreds, if not hundreds of thousands of brews, and if it's not meeting the cut, I would be hearing about it. So the model that's used within that software seems to do a good job. So that's my preference. But getting back
I think what you're hearing is, do your homework, take your best shot at it, and then fine tune it. Don't just go into it blindly, see what happens, and try and adjust from there.
For sure. And of course, you have to have all that information. You have to have your water information. You have to have a decent idea that your grains are going to perform per the model, and most of them do. And don't fret too much about pH. As Denny pointed out, don't fret too much. Get it close. And if you're a little bit off at the end, at that 45-minute mark, remember that. Put that in your brewing log and say, hey, this beer ended up, a couple of tenths higher than I wanted to. Go ahead and say, okay, I need my targeted pH within the software to be 0.2 lower or whatever, and just live with that. So like I said, don't chase your tail. Try to be predictive with the pH, and if you don't hit the pH perfectly, just make sure you got good notes and that you keep a track of how it performed, and there are things like, your water could have changed. Some of these grains could change. So any of these things, they will matter. So and you're dealing with a natural product, these grains that we don't know exactly. We've got a I guess a close but inexact model for.
So if you're within a few tenths at the end of your mash, what I'm hearing is don't try and adjust it further from there. Put it in your notes, and the next time you brew it, try and anticipate that and correct for it. Is that correct?
Correct. Although you can post mash and potentially post boil adjust your wort pH if it's wildly off. Say you're several tenths off from where you really want it to be. For most beers, you're wanting your mash, or I'm sorry, your post boil kettle pH to be in that 5.1, 5.2 range. And if it's not, you can actually use a program like Brewing Water. If you want to drop that wort by another couple of tenths, well, you can just go back to your original recipe file in Brewing Water and say, oh, well, how much acid do I have to add to get that wort or get that mash down? The 2 or 3 more tenths that I want, and it gives you an answer, and okay, what's the difference between what I added and what it says I need now? We'll add that difference to the kettle, and your pH should be fairly close.
What about the inverse? If you end up, it's too acidic at boil, is there anything you can do at that point?
For sure. Same thing. In that case, because those are stronger acids, you can either do well, you could do chalk, because there's enough stronger acids in there that it might be able to knock it down. But of course, baking soda works very well. So shall we answer Dennis's question?
Oh, absolutely.
Okay, so acid malt versus acidified strike water. And of course, strike water has nothing to, I'm sorry. Wait, you, okay. So yes, there probably is a difference, because, all the acid in the strike water has already been mobilized. It's been fully mixed with the water. And by the way, when you're preparing your water, I strongly recommend that you add the minerals and the acids and mix them up very, very well. And by the way, all things like gypsum and calcium chloride and salt and Epsom salt and those things, they might, if you just dump them into the kettle and leave them sit there, they won't dissolve. But if you stir them up with a spoon, voila, they will dissolve. So don't expect a miracle here. You got to help out a little bit. So add those salts and the acid, mix it up, then combine that with your grain, and then you've got a very homogeneous product. Okay, so back to the question.
I want to add something, little tip I do. I use a sous vide stick. And I stick it in there, dial the temperature down so it doesn't actually heat it. And it'll sit there and stir as long as you want to let it go.
Little pump. Yep. So with respect to Kevin's question, I don't exactly know. I am not a proponent of acid malt. I feel that is an inaccurate way to brew. people like AJ Lang are big fans of acid malt because indeed they are just like sourgut. It is a broad spectrum of biota in that acidification. So it's not just pure lacto, which is what the liquid lactic acid is. So you get a little more flavor out of it. So in that respect, yeah, sure. But when you're adding so little in the typical, if you're starting out with a relatively low alkalinity water, you're not adding much in the way of acid malt or any other acid to your water or your grist. So it doesn't really make a difference. So I just cut to the chase and I use lactic.
So, Martin, we're at 28 minutes and we have 23 questions.
Woohoo!
And I can even do that math in my head that if we will try and do these about a minute apiece, we can knock these guys on out. So are you ready to kind of really do these short and sweet?
Yes, sir.
All right. So Scott has the first one. The water in Pilsen is famously soft. But is that water really what they used to brew with? For example, the legendary Pilsner Urquell, I've got to imagine that the yeast would perform much better with more than a few ppm of calcium. What do you think?
Well, so number one misconception, all the calcium that yeast need to perform perfectly is within the malt itself. You can brew perfectly well with complete, DI water and malt. There are things that will not perform as well, but yeast will not have a problem with chewing up that wort. So that's off the table. But with regard to Pilsner Urquell does add, listen to this, gypsum, which is calcium sulfate, to their water because they found, not surprisingly, that having enough sulfate in your water makes that beer crisper, cleaner, and clears your palate, makes it much more drinkable and enjoyable, and it invites the drinker to take another swig. So all these people out there that say, "Oh, I do not want sulfate in my water," you're just flat out wrong. And John Palmer and I allowed a true misstatement to be included in that water book, and I apologize to all of you that that ever made it in there. Sulfate does not affect noble hops. It does not make your beer worse. It's an untruth. It's one person's perception. It's just wrong. So they do add calcium in the form of gypsum. They make a great beer, and it's a bit, just like this Kölsch, big malty, but that PU has got a big punch of hops, or I should say, big punch of bittering and a big punch of Saaz hops to make that just a fantastic beer.
Well, I love that question, but we got to do faster.
Okay.
But I do like the true confessions. That was really good. All right, Justin has the next one. What is your recommendation for boil pH and post-boil pH numbers? I have read advice from some pro brewers that they knock out pale lagers at less than 5.2. I've also read advice to knock out New England IPAs at 4.8 to 5. What do you think?
So, yes, for the 5.2, and because New England IPAs typically add a huge dry hop charge, and dry hops tend to drive pH up. Having that lower pH is actually a real good thing. And plus, having a low pH post boil, makes it again, the beer's talking. Makes a crisper, cleaner, more enjoyable beer. And with the effect of those, the raising of the pH from the hops, that will make a difference. So that is an appropriate advice there for the New Englands.
All right. Thank you, Justin. I like that question. Keith asks, I'm a very small nano home brewer, and I've converted my utility closet into a brewing room. I've installed a small water Pelican filter device that was originally intended for RV or boats. Thought a lot about this, and I haven't used it yet, but from all accounts, it appears to be adequately suited for the job. What think you?
I am not familiar with the Pelican filter. If it's an RO device, okay, that would be good. Personally, I don't like small RO units. I like that have the big canisters, like the 10-inch canisters. That's a way better way to go than the teeny little canisters that you get in these micro systems. You're going to be way better off with something else. But if that Pelican is only like a carbon filter or something like that, sure, it's going to help out with getting the chlorine out, just like Denny said. But other than that, it's not really changing anything. So, and you can live with that, but just understand that it may not be truly changing anything else.
Well, since I have a small RV, I can relate to that question. Now Crispy says he likes his Pelican system. Now, you two happen to go back a ways, don't you? I think he was asking earlier if you still rode a motorcycle.
Oh, yeah.
Okay. We got 20 minutes and 20 questions, Martin. We can't go there.
I know.
Dave says, I have a very high alkaline water with over 400 ppm bicarbonate. I do add lactic acid to lower the pH of the mash, but there is a point where it's better to dilute with RO than to avoid tasting lactic because you need to add so much of it. Am I right?
Oh, he's definitely right. But there are styles where that can be a benefit. I've mentioned that Bavarian water is very alkaline also, and I personally believe that the Weiss beer brewers in Bavaria, they're tending to just charge that. They're not reducing temporary hardness by pre-boiling or anything like that. They're just throwing in a bunch of sourgut, and I perceive that there is some lactic or lactate flavor in there, and I think that's okay in some styles. But yeah, overall for many typical beers, yeah, you're better off diluting.
Good question, Dave. Tom has our next most popular question. What is your preferred method of removing chloramine? Tablets, overnight, or carbon filtering?
Okay, so definitely metabisulfate is always going to be better. It's gonna tack on a little bit more sulfate. That it's several ppm sulfate. Just that's not a big deal. But since you're dealing with chloramine, overnight, uh, uh, leaving it out and letting it vent, it's still, the chloramine is so non-volatile, whereas chlorine which at least my city uses just chlorine. I could do that, but it's just not a way to go. Carbon filtering, chloramine is not very effectively filtered with chloramine. It requires a long contact time for it to be removed, which means that for the typical 10-inch filter, you're down in the I believe it's 1/10 of a gallon per minute. That's like watching grass grow. So screw that. Use the tablets. Metabisulfite, either potassium metabisulfite or sodium metabisulfite. Quick, easy, effective. Bottom line, just be done with it.
Well, that's interesting. So I've been using a shower charcoal filter, and I run it what I thought was really slow, but it sounds like that's totally insufficient.
Well, it depends if you have chloramine or chlorine.
I wish I knew. But it seems okay.
Yeah.
Okay. Next question. Looks like John has our most popular one. If you use a brew software that gives an expected pH, and after 10 minutes, the pH of the mash is way off, what are your options?
Well, my particular recommendation is, 10 minutes don't mean nothing. At least take it out to 30 minutes. Hopefully it has come closer, because as I pointed out in that graphic, pH versus time, it depends where your strike water pH starts off, and you can't. Like I said, don't chase your tail here. So just live with it. Hopefully you've calculated something that is reasonable, and the brew software isn't like out in left field.
I've got John has a good comment here. Can you read it there? On chloramines can last 27 days. I would love for you to comment on that.
I don't doubt that. Chloramines are employed in many water systems, especially water systems that have, we call it water age. So the water sits in the far distant ends of the water lines for like a long time before somebody pulls it out. And under those conditions, it's important for that longevity to be there. So chloramines have been employed for almost 100 years now, and that sure they're the bane to brewers, but they're a really good thing for people like me in the water business.
All right, we have 19 questions, and we're down to 15 minutes. And I've warned you, Martin. This is kind of like buying gas at the gas pump. When you put in $20, it ends far too soon. All right, so Sheldon has the next question. What are the most important compounds to have tested at a lab if I send them a sample of my test water?
Sure.
Most important compounds.
Okay. Calcium, magnesium, sodium, sulfate, chloride, bicarbonate, aka alkalinity. That's it. If you have staining on any of your plumbing fixtures, then you want to have, beer talking again. You'll want to have iron tested and manganese tested also. So that's it.
Good short answer. Wow. Let's keep it up. We won't get to everybody's. Yeah. Thomas has a great question, and I think Thomas is actually in London. So he asks, what's the best profile to use for turning classic hard water in London to soft water for lagers and pilsners?
Well, so in because London no longer uses the deep aquifer, everything comes out of the Thames. It goes into the reservoirs, which dot the Thames upstream of London. It's like I said, it's hard to take those things out. The best option would be to do RO water, but like I pointed out that lager pilsners, or the light lagers, benefit from having water that has very little in it, because it lets it the water is firmly in the background, and just the malt and whatever hops you have are doing the talking. So that's the difference. So you can kind of live with that Thames water and still make a semi-decent lager. The main thing will be to make sure that you're attending to all the alkalinity and making sure that your pH is down where it needs to be. Because if you're doing lager pilsners, I'm assuming light lagers, it's pale, so that means you have to add some acids. And if you're dealing with, and I realize that CRS, which is a blend of hydrochloric and sulfuric acid, I don't think that you want to use that. If you can get phosphoric, you would be way better off. Actually, even lactic would be better.
So I know this is a rabbit hole, but give me a short answer. So there are some regions that have some water that really can't be adjusted adequately for some styles, right or wrong?
True. And that's where dilution comes in. Dilution
Okay.
with either RO or distilled water.
Okay, that's the solution. Okay, good. I didn't want. So we're down to 12 minutes and 17 questions. So we got to hurry now. Daniel asks, how far can I go in temperature with my RO water? 40 parts per million in total dissolved solids for a spargin in combination with lactic acid, so I can turn the pH lower. There is no extracting tannins.
Okay.
And not extracting tannins, I think is what he meant.
And not, yeah, okay. So the water itself shouldn't be a problem. Temperature is, so in my opinion, in my experience, tannins and silicates are extracted when the specific or the gravity of the wort becomes too low. With my system, if I allow the extract, the final runnings to get lower than, say, about 5 Brix, which I can't remember what that means in specific gravity, but 5 Brix. So I feel that it's not necessarily temperature that drives tannin and silicate extraction. It's getting the letting the wort get too thin, and then they're just going to start flooding out of the cells of the grist. So don't oversparge is what I'm saying.
All right, we're going to have to really jump through these. Eric has our next question. So Eric asks, would you target a different mash pH for a lager versus a stout versus an IPA?
Oh, for sure. So it depends on the stout, but most typical stout porters, the targeting something 5.6 or even a little bit higher tends to make the roasty notes fuller and softer. Whereas if you go much lower than that, they become sharp and acrid. So that's the dark beers. And for those paler beers, kind of universally that 5.4, 5.3 range, that's almost always going to produce something really good for you.
All right. Thank you, Eric. Good question. Let me get to the next one. Wish this didn't move around so much. All right. Looks like Glenn's got our next highest voted question. All cooks throw your spices out after a year. What about brewing salts or additives? How long should we keep them? Great question.
Okay, almost all of the salts are good forever. I mean, they're minerals. There's a couple that are not, though. Magnesium chloride and calcium chloride will, because they're hygroscopic, that means that they suck water into them. That means that as they're sitting, even though you've got them sealed up or whatever, more than likely there's going to be some more atmospheric air moisture getting into the salts and changing that. The good thing is that you can, at least for calcium chloride, you can reconstitute those salts by heating them to, I believe it's 200 degrees centigrade, which is pretty hot. I think that's 300 and something degrees Fahrenheit for about an hour. That will drive that moisture that is literally bonded molecularly to the calcium chloride, and it will bring that calcium chloride back to its anhydrous form, and it's good to go. So definitely don't throw them out. If necessary for those two minerals, you might and I don't know what if heating can be done for the magnesium chloride. Most people don't use it, but calcium chloride for sure, that will work.
Insightful question. Glenn, thank you for asking that one. Next one, and again, we need to really make these short, Martin. Or are you going to be answering them in the Zoom call?
Yeah, no problem.
I use RO water to build a style. How does one address bicarbonates? Is HCO3 essential to target? And if so, what's the best way? Baking soda? Should I do it? Or Na plus becomes a factor? CaCO3 is essentially insoluble in water, but maybe not in the mash?
It is almost insoluble in the mash too. So don't do CaCO3 is chalk. Okay, so never let a water profile guide you with regard to the amount of bicarbonate that you need to target. The only thing that guides your target for bicarbonate is the resulting pH, assuming that you're using good brewing software. That the brewing software says the pH is going to come out right with that particular bicarbonate, not by something that somebody said. Oh, even the water profiles within Brewing water, of which there are a bunch, don't just don't even think about it. Just let the pH for your mash and its grist and the water you're doing, let pH be your guide, not bicarbonate targeted. And if you're going to do something, use baking soda, because that's certain to add the bicarbonate that you need.
All right, we're down to less than 5 minutes, and we have 13 questions.
Okay.
Are all RO water the same?
No, but it's in essence about 95 to 98% of the raw water quality. So if some guy out in the desert has got super high TDS water and you, Doug, with your relatively low TDS, if you ran that through the RO filter, they would not be the same. But they're, in terms of difference, they're not that different. But the guy out in the desert with the high TDS water, his RO water is going to be a little more mineralized than yours will be, Doug.
Wow, I did not guess that would be the right answer. All right, quickly, this comes from John. Do I calculate RA on basic water profiles on basic water plus any salts I might add? So calculating RA on basic water profile or basic water plus salts?
Well, so RA is a residual alkalinity is a real thing, and it does affect mash pH. But in my opinion, RA is not something that you should worry about. The only thing that matters is mash pH. So this whole RA question, yeah, I'm gonna have to say, please don't go there.
Well, that almost begs a whole different webinar. But anyway, let's go to the next one. And we may have one or two just questions left. Daniel asks, can you recommend a good and free app software Excel sheet for water chemistry? That's a setup question.
Well,
Thank
it
you,
is.
Daniel.
And I noticed that Brewing Water and Brewer's Friend and things are listed, and there are other ones beyond that. I can't attest to their accuracy, but I can attest to Brewing Water's accuracy, and it is accurate. But some people might look at it and say, because there are a lot of moving parts, because water chemistry is not exactly easy, but it's not exactly rocket science either. So if you read the instructions on Brewing Water and understand what it's doing and what you have to do to get an answer, it actually works. So
hey, if it works, that's what matters. All right. Martin, one more question, and then I think we're going to have to say our goodbyes and then meet up in the chat. I'm just going to pick the longest one, just scanning over it right quick. So Kevin asks, so I just got my Ward Labs water test back. And while you touched on sodium, I was concerned that my Na was 154 parts per million. You mentioned that unless you're over 100 parts per million, not to fret. What's your feeling about 154? I talked to the installer for a new softener, and while it's the most efficient mode now, it could set and add less salt, but then I have more regens on the softeners. What are your thoughts? And you need like 10 seconds, quick.
154 is too high. Don't brew with softened water. Do not brew with softened water. Unless that raw water has iron or manganese or something else that's really screwing up your water, don't brew it with it.
Good.
The raw water is good.
I have 15 seconds to thank you. Everybody else has been putting it in the chats. Listen, hope to see you in the Zoom room shortly. Hope everybody else will be there. I'll post it in the chat.